What's up, everyone? This is LeetCode 199, binary tree right side view. So, given the root of a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. If this is confusing, really what they're just telling you is go level by level in the tree and take the rightmost node, append that to an array, and then at the end return that array, right? So here, for example, right, this level, right, we add the 1, this level we add the 3, this level we add the 4, so we add 1, 3, 4, right? And that's what our output should be, right? Example 2, right, go level by level, right, we have 1, 3, 4, 5, and that's what our output should be, right? Here, for example, I guess I don't have a picture, but the root node would be a 1, and then we would have a 3 to the right, the left side would be null, so we would just return 1, 3. And then obviously we could have an edge case like this where the input could be basically our root node could be null, right? So you got to keep that in mind, right? The number of nodes in the tree is in the range 0 to 100. So you could have 0 nodes in the tree. So that is kind of like an edge case we have to handle. So we will handle that, okay? So let's just handle that right away. So we're going to say base case. I guess maybe not base case, but I'll say edge case. Or base case, I don't know, whatever you want to call it. We're going to say if not root, just return an empty array, right? Because if we don't have a root node, well, there's nothing to return, really. Okay, so the way we're going to do this is we're going to go, like I said, level by level. And we're going to do process the rightmost node. Now, to do that, obviously, we're going to have to use BFS, right? So we're going to have to use a queue, okay? I think you can do this in DFS also, but I think BFS is just much more straightforward and probably in an interview what they would want. Like, even if you implemented some like weird DFS function, in an interview, I'm sure they would ask you for the BFS implementation because it's probably what they would expect. But so the way we're going to do this is we're going to create a queue, right? Create a double-ended queue, put the root node in there, right? And again, we will always have a root node because we handled the edge case up here where it doesn't exist. I'm going to say while there's something in the queue, right, we need to process it. So, and again, we're going to have our answer, right? And we're going to return this answer here. Okay. The answer is just what our output is going to be. Now in this queue, because we're adding child nodes of particular nodes and stuff, we need to basically define what range of nodes we're looking at. Like, for example, if we add the nodes 2 and 3, right, we're on this level, we obviously only want to handle the first 2 nodes, because if we add this node here and this node here to the queue as well, do we want to process 4 nodes at once? No, we only want to process 2, right, because we're at this level. So we only want to handle the first 2, right? So we need to basically define that by defining basically how far our for loop is going to go. And we'll do that by basically just getting the level length, okay? And so we're going to get the length of the queue. So before we append anything into the queue, we already have the level length. So now we can actually use that in a for loop, right? So we're going to say for I in range level length, okay? Now if we add stuff to the queue, it doesn't matter if it's expanding or not, the size, right? Because our for loop already has a defined range, right? So we're going to take the node that we're on and we're going to pop it, right? Because we're going to go basically pop from the left of our queue, right? Because that's how we're going to process it, like sequentially, right? So we're going to say node is equal to queue.pop left, right? And there's really a couple things, okay? So first of all, if it has child nodes, we need to add that to the queue, right? So we're going to look to the left and to the right of this current node that we're on, and if it has child nodes, we're going to add that to a queue, okay? So we're going to say if node.left, right? If it exists, then we're going to say queue.append node.left. Same with the right, right? If node.right. I don't really want to add empty null. I mean, you can add null values if you want, but I'm gonna do these if checks because I just want to add nodes that actually exist. So we're gonna say node.right. Okay, now there is one thing, which is the rightmost node, right, on a particular level. How are we going to add that? Well, we already have our defined range, right, for how far the level should go, right? So that's what level length is for. So when we're at the end of this range, that should be the rightmost node. Because even if we add other nodes, right, we're not going to look at those because they're from another level below, right? So when we're at the end of this range, that's basically when we have to add that node to our answer array, okay? Because that'd be our rightmost node. So we're going to say if I is equal to level length minus 1, right? This is basically the rightmost node. We're going to do we're going to do a res.append node.value, and that basically is our rightmost node for that particular level, and that should be our code, okay? So yeah. Whoops, forgot my colon here. But yeah, I don't think this code's too complicated. I mean, there's a lot of ways you can write this. Sorry, I called it res. I actually called it answer up here. I think I had some other code before that I called it res when I did this the first time. But this code isn't too complicated. I think it's quite simple actually, but there are a couple ways to kind of approach this problem, but I think this is kind of the easiest to understand and memorize. I mean, you shouldn't really have to memorize. It's kind of straightforward, but I hope it helps. I don't think it's too complicated, right? You're just going level by level, right? If it has child nodes, you want to add that to the queue. Once you reach the end of the level length, right, you want to add that node to your answer array. And because the queue is expanding potentially, right, that's the point of level length, is so that you only handle nodes from that particular level. So if you add more to the queue, you don't handle those nodes quite yet, right? That's kind of the point of this variable here. Yeah, it's really, I mean, this code, I don't think this code is too hard. Definitely on the easier side of mediums. There's a lot, like there are some medium problems that are way more complicated than this. Now coming up with this on your own may be a little bit complicated, but just seeing the code, not too complicated, right? But anyways, I hope this helped, and I'll see you in the next one. Peace out.